from Youth Global. Thanks for joining the webinar. I think we have a lot of attendees join the session. I think it's the time to start the session. Docker one-on-one tri-series webinar. This is the first series webinar we are doing from the Docker side. We will communicate you with the second and third webinar series with the login details after this webinar got completed. So a quick brief about Youth Global, what we are into so far. We are founded in 2004, headquartered in Dallas, Texas. We have been present in multiple locations in USA, and we have three offices in India at present. We are the leader in DevOps transformation, cloud enablement, and test automation. We have separate center of excellence built for each and every of these service offerings. We are one of the top 100 fastest growing companies in Dallas twice in a row. So our clientele includes Fortune 50 companies. Majority of our customers are from the Fortune 50 side. So today here are our speakers. Venkat Tirunalai is a DevOps practice leader. His area of expertise includes DevOps and cloud. He consults enterprise customers on DevOps IT strategy, responsible for building the global pre-sales, consulting, and delivery teams for Youth Global. He has overall 16 plus years of experience in IT industry and has delivered multiple enterprise scale projects for Fortune 500 customer base. And we also have Jayakati Dhanbalan, AWS solution specialist from Youth Global. He has extensive experience in working with AWS, Ansible, Jenkins, and DevOps, and in the system administration on Linux and Windows servers. He possesses more than 6 years of experience in IT server administration with Linux and Unix. Here are some of the housekeeping instructions. By default, all phones are set to mute. If you have any questions, please type them in the chat window located beside the presentation panel. We have already received several questions from the registrants, so we will be answering by the speakers during the Q&A session. Towards the end of the session, we have reserved a 15 minutes time for the Q&A. We can even extend based on the need. We will continue to collect more and more questions during the session. If in case we could not answer any of your quick questions, we can we can answer them or an email. So again, thank you for your participation today, and enjoy the session. Over to you, Venkat.
Yeah, thanks a lot, Satish. So I'm Venkat. I am the practice lead for our DevOps practice within Youth Global. So what we're going to talk about is a quick introduction to Docker, containers, and metrics from hell, and the separation of concerns that Docker really brings. We're going to have some technical discussion, and then we talk about the Docker ecosystem, Docker basics. We're going to cover Docker file and Docker Compose and Docker Swarm at a high level as a concept in this entire webinar. So basically, the way application develop has really has evolved over a period of time is that we have huge number of application stacks. It's no longer JavaScript, J2E, and Oracle. It's a very wide range of technologies that are there, and also the number of hops it takes before it reaches a production, right? The cloud test environments, the QA servers, the production servers, the laptops of developers, all these things add to a lot of permutation combination, and they lead to what is known as the matrix from hell, right? So if I have, let us say, a QA server, and then it's the tech stack is a static website. So will it work there, or will it work on, let us say, the contributor's laptop, or eventually into the customer servers, right? So end of the day, the number of permutation combination of your tech stack and the environment on which it's running has increased exponentially, making the software delivery process extremely complex and challenging. So let us take a step back and kind of envision how what this problem is, and let's take a parallel example from the mundane world where we have multiplicity types of goods. Like you could have inflammable goods, you could have fragile goods like a piano, or really heavy goods like a car, which is, by the way, also fragile to a certain extent, or you're talking about just shipping coffee beans, right? So, and then there are multiple modes of transport depending on where your point A and point B is. It could be a truck, it could be a ship, it could be a flight, and so depending on these combinations, it was actually really complex to kind of ship the goods, ensure that the goods were never damaged. There is basically some damage to the data, and then customers were kind of dissatisfied. Okay. So they also experienced kind of metrics from hell, where basically there were so many permutations and combinations of the goods and all the transportation services, right? So let us see how this particular challenge was addressed. So most of the shipping companies came up with, let us say, a standard container that you can load any good, and you can manipulate the size of the container depending on the size of the good. So you will this will whether it's fragile, whether it's inflammable, you can add in some more components in this container as an add-on, and kind of this can be transported, loaded, stacked, etc. across multiple transportation mechanisms, right? So, and this made the entire process, so the people who are shipping the containers didn't really have to bother how many hops it takes before it reaches the destination and what is the mode of transport. The fact that it was well packaged in a container meant that it would be safe and sound and delivered properly to its destination. Okay. Now similarly, basically, what is Docker, right? Docker is that engine or that container that enables any payload or application to be encapsulated in as a lightweight, portable, self-sufficient container that can be manipulated using standard operations and run consistently on any hardware platform, so that it's like I develop it in my desktop, it works in it may not work in the development machine, it works on my machine, it doesn't work here, it's not my fault, it's yours. So these type of conversations can be avoided, and this greatly improves basically the application agility. As you can see, Docker eliminates the matrix from hell, right? So it doesn't matter whether it's a static website or a web front end. You define basically, your container specifications. You define basically, you define basically what the parameters are, what the size of the containers, and so on, and then you can kind of package it and put it on different environments, and this greatly helps basically the entire deployment process. It simplifies a lot of things in production. It brings the highly desired kind of portability that all the developers desire, and this explains a great reason for Docker's success, because it saves a lot of time for a lot of people and eventually is highly beneficial to all the developers and the entire life cycle. Okay. So why do developers care for this particular environment, right? So basically, you build once and then you finally run anywhere. So basically, you get a clean, safe, and a hygienic and portable runtime environment for your application, right? You don't have to worry about missing dependencies, packages, and other pain points during subsequent deployments, right? And you run each app in its own isolated container, so you can run various versions of libraries and other dependencies for each app without worrying, right? And then you also basically leverage on automation testing, and and you can package everything, and anything that you can script, you can actually take it as a container and kind of deploy it. Okay. You can reduce and eliminate concerns about compatibility on other platforms, either your own or your customers. And I'll come to the differences between a Docker and a VM. So Dockers are really lightweight, and they don't have the overhead that a virtual machine brings to the table. Okay. I'm sorry. Right now, most of you, I'm sure, have heard of DevOps and are basically aware of the goals of DevOps. So we need to bring in more and more agility into the process. We need to be really, take code to the environment very quickly, and basically we need to eliminate inconsistencies between development, test, production, and customer environments, right? And then we need to significantly improve, with the help of Docker, basically we are able to provide that speed and reliability that DevOps demands. And also because the containers, as discussed, they are extremely lightweight as compared to that of the virtual machines. Basically, it kind of you can have more number of containers or more number of apps in a given host than number of VMs. So that also makes your operations a lot more cost effective. Okay. So basically, why this separation of concerns and packaging containerization works, right? So basically, the developer, he is able to, he is the one who worries about what goes into the container environment, his code, his libraries, his environment, and then once the container is built, all the Linux, containers look like the same. He's able to scale it up based on a script, right? And then there is basically, the operations guy, who kind of worries about what's outside the container. He looks at logging, remote access, monitoring, network config, and so on, right? So all containers start, stop, copy, attach, and migrate exactly the same way. So basically, there is a good harmony between the development and all, and the operations team, and they are able to kind of, execute, their work in a very seamless and smooth manner. So a little bit, getting into the technicalities, right? So basically, why you're able to run everywhere, right? End of the day, basically, regardless of the kernel version, regardless of the host distro, physical or virtual, cloud or not, right? So container and the host architecture should match. That's one caveat. But basically, if it can run on a host, it can run on a container. If it can run on a Linux kernel, it can run. So you can get it to run, albeit with some kind of tweaks that you need to put in. Okay. So what is this? It's basically Docker container is its own. It's a lightweight. You can visualize it as a lightweight VM, so which has its own process space, its own network interface. It can run things as root if required, right? And it can also have its own /sbin in it, right, which is different from the hosts, right? And then it's like basically it's low level. It's like a ch root on steroids, right? So that's the reason why it's able to kind of operate at very low resources. So the kernel remains the same, and then it's a sandbox environment on top of the kernel, having its own process space, so that therefore I can occupy minimal resources and have more number of containers than the equivalent number of VMs that are required on top of a hypervisor. Right. So let's go a little bit more into the visual depiction of containers versus VMs. So basically, let us say that you have 3 VMs out there, and typically you need to have a hypervisor. Sorry for the font out here. So this is the hypervisor on which a particular guest OS runs, and on that guest OS, basically you have applications like A-B, right? So these guest OS are different operating systems, or probably the same Linux operating system with different environments that are running different bins and libraries, and are hosting the app on top of them. Now, because they are hosting a guest OS on top of a hypervisor, which is also an expensive process, a lot of resources, system resources, are getting directly consumed and wasted in just to support this operating system. Now, in the case of the Docker, there is a Docker engine which runs on directly the host OS, which is basically a Linux machine. And there are various Docker apps that run as containers, right? And you can have therefore more, and there are no overheads of having a separate guest OS. Okay, so that is why we are able to have a larger number of apps installed in a container running on a host OS of comparable compute as compared to virtualization, right? So basically, and this architecture, it results in significantly faster deployment. It has got much less overhead, easier migration, and faster restart. So basically, let's go a little bit more deeper, right? Why are Docker containers kind of lightweight, right? As I mentioned, every app, every copy of an app in a VM, and every slight modification of the app requires probably a new server which you want to bring up and kind of update and maintain. And as I mentioned, the guest OS requires a lot of system resources to kind of operate, right? And on top of that, let us say, like in a container, I want to basically I just have the app and its runtime environment. I don't need a separate guest OS. Right now, if I want a copy of the container, basically we can ensure that the copy of the container can share the same bins and libraries. And then the modified app, if you want to modify the application and put in the changes, basically you can do it in an incremental fashion, right? And we can save only the difference between container A and A dash, right? So we can maintain both the versions, roll back to the older version by maintaining only the differences. And this greatly improves the system resources that are occupied. So in case of a VM, if you want to maintain different versions and other snapshots and other things, you'll have to maintain 2 separate images, and hence you will be like consuming more resources, and you're not as efficient as you are required to be. Okay. Right. So basically, what are the basics of the Docker system, right? So there is basically a Docker file where which is nothing but a text format file where you can store a series of commands that will help you to build what is known as a Docker image, right? And then there is basically a Docker image, and whatever that you are building, you can push it to a Docker registry or a Docker hub, where the entire image can be stored in multiple incremental versions of the code that you have written in the Docker file. And any end user who basically wants to have your environment, right? And this Docker image can contain, let us say, a Tomcat. It could have a Java runtime environment. It could have, let us say, a MongoDB or whatever you have baked into the image and put a command in the Docker file. And then you could incrementally store it into the Docker registry. And if somebody wants to just quickly deploy, a MongoDB or something like a Tomcat or something, you could use, all you need to do is run a Docker pull command, and automatically it will, depending on your proxy setting, you will pull out either from the public registry or your own private registry. You can pull out Docker images, and then you can spin off any number of containers either through command line or through scripted operations, and that's as simple as that. Okay. And how do you do changes and updates, right? And before I get on to this slide, I would like to explain, most of you are conversant with the term infrastructure as code, right? Now, we all know that, in the olden days, like 10 years ago, procuring a hardware in a system and, getting it into your environment was like it needed approvals. It had a, procurement cycle. The vendors took time to supply the hardware, etc. on you, right? And deploying and configuring that hardware to your environment was 2 days, but it was peanuts as compared to the entire life cycle of procuring the entire hardware. So nobody really worried about the time to require to configure. Now today in the cloud age, where infrastructure is available at a click of a button or a simple cloud formation template or an API call, right, 2 days is still it's not something that you can forgive. Also, in a DevOps world where we put changes very rapidly, and changes are not just code changes but also changes in configuration, changes in environments, and so on, right? It's very important that you version your infrastructure changes incrementally. You store it as the way you store a Java code and version it properly. And so it's very important that you have a text representation of your infrastructure, which you can incrementally version, label, downgrade, upgrade on demand, so that it's uniformly, consistently available to every operations guy, and you are able to kind of execute in a very consistent manner. Also, we live in fact today's trend is totally on microservices and microservice architectures, which require entire application to be broken down into multiple services. And you shall be seeing in the subsequent Docker trilogy seminars, right? We are going to Dockerize, we're going to take one large application, break it down into 400 to 500 microservices, and each service will be encapsulated in a Docker container and deployed independently. Now, if I have to make changes and apply to all the 500 containers, I cannot do it, and also maintain the versions, the downgrades, upgrades, etc. It's very important for me to kind of, version the infrastructure changes like source code, label them and maintain them the way we maintain source code. And that's why the term infrastructure as code. Okay, so basically, how we can manage the same thing in Docker is we have a base container image. We can apply a modified change, and then we have put another modification. And when you are pushing all this, all these are stored incrementally. So I can revert back to this state or this state on demand, so that I don't have to do a whole lot of configuration and mess up my whole environments. Right, so it's a very clean and professional way of managing your infrastructure at scale. And as you will see in the subsequent seminar, the trilogy webinars, that what is the importance is a very powerful feature in Docker. Okay. So basically, we are able to store incrementally into the Docker registry, and then when you pull, we are able to pull only the incremental updates. So you don't clog your network by pulling the entire image every time. Even though the Docker image is minimal, the upgrades come only as diffs, and you don't need to really, pull the entire image, so that you are saving your bandwidth and you are making your operations kind of really efficient. Okay. So couple of things in the Docker vocabulary that you need to be familiar with as a take home today. You need to understand what a Docker image is. Basically, it's it represents a full application. It's an image that represents all your installed like it could be Ubuntu 14.04, it could be a Tomcat, it could be basically the the Java runtime environment, and so on. It represents a complete application stack. Okay, Docker container, that's a standard unit in which the application service resides and executes. Docker engine, basically one that kind of runs Docker containers on a physical infrastructure, and that is a registry service. So think about Docker Hub or a Docker registry service like a GitHub for Docker images, right? Where you can store and version those images. Okay. Now, with this, basically, and then there are some image layers, right? As I mentioned, there will be a this is just an indicative example, right? You could have the entire image baked into layers, and then you can even kind of roll back to this particular layer and abandon the other two if that is not suiting to your requirements, right? So it's a complete very structured way and a very modern way of managing your infrastructure. Okay. Now with this, I would like to hand over this presentation to my to my senior solution architect Jay Karthi, who is a subject matter expert on Amazon Web Services, Docker containers, Ansible, and Kubernetes and scaling containers in production. Okay, so I'll just hand over the presentation rights to my colleague. Yes. While my colleague Jay Karthi kind of gets ready with his presentation, I would also like to quickly talk about the Docker file system basically. Okay, so basically it's a logical file system, basically by grouping different file system primitives into branches like directories, file systems, subvolumes, and snapshot, right? And each branch represents basically a layer in Docker image, and basically the Docker file system allows image to be constructed, deconstructed as needed, versus a large monolithic image which is there in the virtual machines. The thing is, in virtual machines you apply changes, you get one single image, whereas in Docker the way the file system is organized, and please pay attention, this is a very important aspect of Docker, right, where we are able to kind of create the entire virtual machine in layers, right, and we are able to kind of version all the changes, right? So when a container is actually starting, a writable layer is added to the top of the file system. Okay. All right.
We need to come to one.
Yeah. So over to you now, Jay Karthi.
Hi, this is Jay Karthi here, working on with Docker Kubernetes and pretty much using it all in AWS environment. So I'm just here to provide and about explain in detail about what Venkat started with, and it will be all sort of the Docker vocabularies we have seen so far. You will be proceeding in it in detail in the practical. So what is it? A layer that really means is like it's a overall in a way to say it's a server with file system, storage space, whatever it is, how the resource is going to be used. So that's what the concept of Docker image is, how it comes into picture, how you are going to split up your resources and how you are going to run. So the ultimate point here is like we are going to be running in Docker, like all the portable applications that can be moved in so random and easy, quick. So that's all it matters. And the portability in the sense how you could be moving an application from one environment to another, and again to take up a snapshot, that is like porting a Docker container from one machine and then storing it at a Docker registry and creating like it's a repository that we use to store the source codes. So that's a brilliant way of producing our contents to other developers, and that makes our continuous development and collaborated works quicker than we expect. So it's all about the layers that we make. So as Venkat followed up with the previous snap, we all start off with requirements. So it's about the Docker file that is going to be taking in all the requirements from one single file. So once you start up with the Docker container, you would be starting up the build of the Docker image. So the Docker image, as I say, is a bare base metal, and it's going to be a base image that is going to have nothing but a very basic amount of script that is like a shell environment. On the top of it, whatever tools that we need, tools in the sense I refer to the application that we are going to run, that should be having sort of requirements, like it should be having something like a Python, and it should be needing a tool like pip to add additional features in and to bring in some components that application really needs. So we bring in all the basics through the Docker file. So whatever we need, whatever we want, we will be bringing it in, and we will be proceeding with the build. It's going to be just a simple command that we're going to use. It's going to be a Docker build that starts up the container, and then it starts the provisioning part. So that's the key, what we exactly use here. So every time that we use a Docker build using the Docker file, that is going to provision up with plenty of components that is going to be done on the Docker image. As you can see, this is a basic bare, a basic level of application that has a Docker file, which starts up the container with the Python and pip tools already readily available, and it's going to deploy a Python app, and this Python app has some specific requirements that needs to be specified, and a specific port like say 5000 needs to be exposed. So this could be done as just like that. You just have to do expose 5000, that's it. And once you run, the running part, it makes it really like easy, that you just have to say like Docker run D, and D refers to the daemon part, and then it's a -p that holds the port that is going to be used for port forwarding a Docker containers port to the external port. So that really makes sense. So that brings in a huge availability for a port that is going to be used. So the exact commands that we use here is going to be like it's a Docker pull, Docker images, Docker run, Docker ps, Docker stop, start, and then Docker attach, Docker rm, Docker rmi. So rm and rmi, what really makes the sense here? It's like rm is going to remove the image and rmi is going to remove the image. But exactly to be very specific, RM is going to remove the container ID, RMI is going to remove the image ID. So it's a version Docker container that we are planning to discuss about in detail. So that's why there is two separate commands that is available. So Docker build, exactly like it pulls from the Docker Hub registry, and we just have to give the repository and the version which exactly we need. We could always go for the latest, or if we bound to use something, a downgraded version or any specific version that we need, we could always specify that as well. It is very easy, like we just put in docker build -t and then the version that we need from the repository. So it will be like Mike G Coleman / catweb is going to be the catweb is the application, and the first part, the prefix, holds the responsible author of this repository, and the suffix part 2.0 refers to the version that is going to be pulled and built. Again, the last one, Docker push, what it exactly does is like we, after taking up a base Docker image or something that has been built, we have this tendency to do some works inside, and we always often end up with like doing some sort of customization as per our requirement to the application that we really host, and we do the pull. So it's always getting versioned. So that's the point. So we always have to keep the repository updated to the latest version, and this Docker push is the command that we need that is going to create the versioned Docker images available to our end users. So it's all a simple syntax that we see here. Like that's going to be a run is going to be a simple run, and then what is the exact command that we need. If it's a Alpine Linux, it's all about like a base level Android Linux OS that is being used as a platform, and whatever app that we need, we would be using a package manager, which is like for an Android sort of platform, it would be a APK manager. So if it is done, then it is going to be the pip install that we normally use for a Python app, say it's a Django Web 2.5 or it's a Flask sort of framework that we use for Python. Then it would be like the pip that is the key player for installing all the requirements into the Docker container. So once all these are done, then it would be the copy command that we frequently require to do some changes or modification. As it is a Docker container, we don't normally use like something like move command, or it won't be necessary to do sort of move, but rather we would be doing something like copy. So if anything that happens, it would be like it's going to be again a container that we have to build it again. That's it. So it's that simple. And if there is a command that we need to execute, that would be the CMD. So it's all like human readable and easily commented. So everything makes really a good impression, like any newbie could easily start writing his own Docker file and get its container up and running in a matter of minutes. So these are some previous slides that I have got. If it's a Ubuntu based base machine that we have got, then it's a run command that is going to be followed up by the package manager, which I actually mentioned in with the previous slide. It's going to be the apt-get that we use for Ubuntu. If it is going to be a RHEL based one, it's going to be yum, and if it's a Fedora image, it's going to be something like DNF. So all these things really make sense because the package manager is what that we need, and then the install is the follow-up command that we have to follow with the as an argument that we have to follow. So to give the exact instruction that we need to be happening inside the container, followed by the component. So that's the component that we need to be installed. If it's a memcache, as it says here, then this component is going to be getting installed by simply executing a run command. So all that we have to know is like from Ubuntu, run apt-get install -y memcache. So that really makes sense, right? It's a very easy sort of stuff that everybody can do at a snap of finger, that it makes your time so quick to get started. Docker run Ubuntu apt-get install -y memcache is going to be creating a base platform, and it gives you a base shell environment that you could use, and then this follow-up command apt-get install and then the package that is going to be installed, all going to be executed as a sudo terminal. So now that's a real difference that really makes sense, right? Because it's a Docker container again. Either we have to container has to be attached, or we have to manually SSH into a running container to execute a script. that we normally do with the Amazon EC2 and EC2 container service, but here it is a very simplified that Docker run executes it as a Docker sudo terminal, and then it comes back to our normal platform. So once that sudo terminal command gets executed, if it's done, it comes back to a normal shell or it's a CMD, whatever it is, then we just have to get to save the changes what we did. It's a Docker commit XXX. So once all these are done, we just have to be proceeding to, like as I said, it's going to be the push command that we frequently use for frequently versioned Docker container images. So Docker run, how it really helps with automation. That's the key point here we just have to focus on. Docker run comes in with the additional flavors like Docker Compose, Docker Machine. Now this Docker Compose has this YAML scripts that is being heavily supported on containers. So the provisioning is the key, and these YAML scripts are again like a similarity in Docker files. So it's very easy to start up and it gets going as when you start writing. So once the script starts written, we just have the curiosity to get it executed and to see the end result, how it really executes and it works. So that's the key point. So once the provisioning starts, all we have to do is like the application has to be up and running, and we just focus on the application execution. That's all the key that we focus on with the Docker run. So that's the Docker Compose that we use. It's a basic example that I am giving you here, how to get it installed and getting you to be used. So all that we need is a version of a Docker Compose that would be freely available with GitHub, and we just have to pick it up and then get it called into our running instance. Either it could be EC2 or it could be some base platform of a virtual machine where it would be getting it as a script, and then it would be migrated to a different name, say like Docker Compose. It's all like renaming with respect to the version that we get it in. Once it's all up and running, we just have to go for a init site that is like Docker Compose or anything with that starts with the word Docker has to be initted. Initted in the sense has to be started, and it will start pulling up its own environment, just like what Vagrant does. So now here in this example, what we do is like we are just giving it as a Docker Compose space up, and then it's a -d. -d, as I said, it's a daemon that we make it up. So whatever happens in the script, it's not going to be like closed. It's going to be running in the backend. So we could get a more clear visibility what is happening with the scripts. So now once that up process is done, it's going to launch up 2 instances, and we could easily get to them like with the PS. So the PS here really indicates the process that is being running, or is it exited, or what is the status. If it's having some error, all these things we have to check, then we would be focusing on with the process command here. So the YAML script that I just spoke a couple of minutes back, that it's going to be having the same content we just saw with Docker file, but it's going to be like something of more similarity in automation that you could frequently find with Ansible, that you could easily identify if you are an Ansible scripter, as I prefer that. So the image name that we want it to be running in, the links, what are the containers that we are going to link it with, the ports that we need to be forwarding in and out, and all the forwarder ports are going to be with the secure line, like say overlay networks, and then it's all the environment variables that we need to set it up here. So the environment variables that we use here, it's going to be the DB username, password, and then the DB name. All those details we are just passing it as it is. and then it's going to be for everything that we need in to be like up and running. We can define it in one single file and we can execute it all at a one single stretch. So as I said earlier, it's all like up and running with a Docker container is very quick, and it makes your automation very pleasant and smooth. Even the error and the debugging part is also like so easy that you could start up with it so quick. So once you just got the Docker machine component in your base platform, and then you're going to rename as you did for Docker Compose, you just have to execute the script, whatever you got. You just have to give the permission for the script to execute, and then you just have to run with it. That's it. So all the way it goes, it all starts up so easy and quick. And the default ports that is going to be used for a Docker machines is going to be like 2376. It's a very frequently used one. And then Docker has its own way of exporting all the environment variables. Like just we saw, it's going to be again the same export and the variable name with the values or the parameters that we need to pass. Once all that's done, we just have to check whether the Docker images are available or not. We just have to give Docker space images. That's it. It's going to give you the version and the name and when it is created, what is the size. So that clearly makes sense how the file system is getting up here and the image layers that we have. As we could see, two MySQLs being used here, and which one is the latest and which is the older one, and what is the size difference between the two MySQL containers, which clearly indicates there is a versioning happening, and again there is a space utilization being made by MySQL DB that also adds up to the virtual size. So that's it. We go into some practical stuff. So the key idea is like I just have to show you some Docker containers, and I would be showing it to you right away.
Switching the screen.
I hope my screen is visible to everybody here. Like I'm showing you right away with the Kubernetes master and the slaves that is being controlled as what we call it as Docker containers. It's going to be on Kubernetes terms, it's going to be pods. So every resource usage that is being made is like accountable and it has to be used properly. And in terms of AWS, we have to be very cautious about the instance and the resource availability and the application uptime, downtime, scalability, high availability. So these are the frequent terms everybody get to know on every daily basis. And the problem, the point of view that I will be seeing at containers is like they always have this high availability nature. What I would like to demonstrate here as well is like if I'm going to kill let's say two instances have gone unhealthy, it's going to like say it's going to start up itself and then it is going to be connected. So on the front, I am just killing in front of you two of the Kubernetes instances. It's going to establish itself again and doing nothing, and it's up and running in a matter of minutes. All I have to do is just refresh. That's it.
In the meantime, if you have any questions, please do type in the chat window, the questions panel. We will address it towards the end of the session. We already have received a lot of questions, and we would be happy to address any of your questions that you may have. Thank you.
Yeah. So, about creating the this presentation. Yeah, I'm proceeding with the Docker.
So basically the question is bringing more flexibility in application deployment. It appears we have more complexity for administration and configuration, right? And what are the tools or methodology to facilitate, the organization? So thanks a lot. Docker has multiple tools like the Docker file we talked about, and also there are several Docker commands. In addition to that, Jay Karthi also showed you a YAML file which is part of an Ansible, where we can automate a lot of things. Now, coming to the complexity of operations, it is a lot more simpler than working with an image on a virtual machine and every time creating a new snapshot and then maintaining that snapshot separately. It's a very cumbersome process. You have to remember the snapshot versions, etc., and it kind of becomes very bulky and difficult to manage. Certainly, managing with Docker, once you are comfortable with scripting, is a great manageable, a great way to manage your infrastructure. Okay. The next question is, can you explain the difference between Docker and VM again? Sure, I'll do that. So basically, Docker, VM is basically nothing but a virtual machine. It requires basically a hypervisor to run on top of, depending on the type 1 or type 2. Let's say it's a type 1 hypervisor. A hypervisor software has to run on top of a bare metal, right, or a server. Now, on top of that, I have to install multiple guest OSs to get multiple VMs or multiple environments. Now, if you have noticed, one simple Windows operating system or a Linux operating system, when it's running, it takes minimum half GB to 1 GB RAM, right? And then on top of that, the application has to be configured. So this is basically virtualization, and the output that you get are basically called virtual machines. Now, Docker doesn't require a hypervisor in the first place. It runs, and again, it doesn't need a guest OS as well. It uses the same Linux kernel, but creates a sandbox with its own, process space. If you want me to explain Docker in very simple language, I will call it a sandbox, sharing the same system kernel with other Docker containers, having its own process space, period. And that makes it extremely lightweight. In addition to that, the file system where you can create multiple replicas sharing the same libs also makes it much more lightweight. Now, if you want to create replicas of VM, you are creating different individual spaces for the same libraries and environments that you are creating, on the guest OS, right? So that kind of explains a significant difference between the between the virtual machine and Docker containers. Okay. Can you explain the term guest OS? So guest OS is nothing but, so basically in virtual machines, the operating system on which your application runs, right, on your hypervisor or your virtualization software, you create multiple VMs. The operating system, on which the VM is running is called the guest OS. Okay. Now, the next question is, do you need to make any changes in the WordPress image to use those environment variables for the MySQL DB? So the answer to the question is, if it can run on a Linux machine, I can use the same deployment structure to run on a Docker container. And Jay Karthi, you want to add anything to this?
Of course, that would be the break point here to say Docker containers, all it runs is like it very much capable of running on even a para-virtualized environment that we saw. Even with an AWS para-virtualized Zen-based VMs, VPS, or a dedicated machines, wherever it is, Docker could be easily up and running. That's all I have to add.
Does the from pull an entire Ubuntu image over in this case? You want to take this, Jayakarthi?
It's not a full-based Ubuntu image. As I said, it's going to be a base bare metal. That's what we will get here. It's going to be a shell, not even a bash environment you would be getting with all the Docker images. It has to be like, you have to check with the Docker repository before pulling in whether it has a bash in it or it is going to be a simply SH environment that you get from that.
I heard not all applications can be Dockerized. Also, like incremental services like SSH, Docker image, something like that. You want to address this?
Not exactly. It even with the Java applications, it could be like adding up monolithic and microservices can be Dockerized, and PHP, Python apps have been Dockerized. Python very much supports Docker. It would be like very easy. You could provision it as you shown in the Docker file. And even if it's a PHP with the Zen framework, it gets easy to migrate on a Docker-based one. Even with the Java 6-based ones, they might be having some Docker, like a dependency issue could be there, possible, but it can also be overcome. There are always workarounds available for it.
Right. You can also Dockerize databases like Oracle, MongoDB, etc. Somebody asked what about the database and other things. Yes, you can Dockerize all of that. One thing is please share your experience with Docker Swarm instead of Kubernetes for multi-host. So basically, Docker Swarm and Kubernetes, Docker Swarm has got built-in overlay networks, which means you can communicate securely across all containers. This was introduced early in 2016 January. Whereas Kubernetes, you need to use a third-party tool like Flannel, to kind of ensure masking of ports and secure communication across multiple services. But Kubernetes performance is a lot better, and Docker Swarm, a lot of the features are still in the preview stage. Docker Swarm also has a new dashboard which is akin to Kubernetes. So generally, while a lot of experts might differ on opinions, we as an organization are an SI, we are neutral, but from what we have seen is Kubernetes, we are very satisfied with its performance in production, and we generally prefer Kubernetes over Swarm. Even though Swarm, the way the features are coming, is looking to dislocate Kubernetes. As of today, given where Swarm and Kubernetes are, I would I would like to put it on Kubernetes at the moment. Okay. Right. So what is your recommended OS? Basically, any x86-based Linux OS would work fine. Generally, we work with Ubuntu 14.04 or 16.x LTS version. But yes, you can work with any Linux 64-bit operating system. And how to access Docker repo registry to available. So the simplest one is you can go to the Docker Hub, which is publicly available, where you can get a list of images. Or if you look at the the Docker docs, you can understand how to create your own private registry, where you can the Docker toolbox basically. Okay. And what I heard is Docker better suits web application. That is not true. Any application that runs on a Linux kernel as a standalone, you can actually Dockerize it. And at least I have not come across a scenario where something runs on a Linux virtual machine or a hardware and that cannot be Dockerized. Okay. What is the difference between Docker file and Docker image? So Docker file is a source code which you can it's like the difference between source code and binary. Docker file has a command that builds a Docker image. Okay. Okay, the command after run should be the command to be able to run with the base image, right? So the Jaikarthi, if you can kind of answer that question.
Yes, it works exactly like it's a sudo terminal as we discussed. It's going to be the command that whatever that follows after run. If you are not specifying any sort of shell environment, say like something like /bin bash or /bin sh, if you don't specify it as by default considered as a sudo commands that you want to be executing it inside a container. Once it is done, it returns back to your environment shell.
So here we will take one last question. I think we still have a lot of questions to be answered, but in the interest of time, we could not cover all these questions. We will try to address all this over an email
or next webinar as well.
So here's the last question that we can cover for today.
What kind of monitoring tools are available for Docker? We could always use like something like Nagios that's freely available, or we could straight away go for something like we have plenty of them in detail. I don't really get it now, but free open source version comes in first priority.
Right. So thank you so much for joining the webinar today. So if you have, we have some more questions to be addressed, which we can send it over an email. And in the meantime, if you have any questions, please do contact us in the following details that I have mentioned in the slide deck. So please reach out to us, and thanks once again. Thank you for joining the session. Thank you.